Copyright University of Auckland, all rights reserved. The content and delivery of lectures in this course are protected by copyright. Material belonging to others may have been used in these lectures and copied by and solely for the educational purposes of the university under licence. You may record the lectures for the purposes of private study or research, but you may not sell, alter, or further reproduce or distribute any part of these lectures to any other person. Failure to comply with the terms of this warning may expose you to legal action for copyright infringement by the copyright owner and/or disciplinary action by the university.
Good afternoon, everyone. For those of you who don't know me, I'm Jennifer Eccles, who's been sending around all the emails. But as the Auckland branch representative of the Geoscience Society of New Zealand, it's my great pleasure to welcome our 2015 Hochstetter lecturer, Nick Mortimer from Geoscience in Dunedin, here to Auckland today to give not just this lecture, but the main event this evening, which is at 7:30, Art of Engineering. So Nick hails from the UK, did his PhD at Stanford, and then came to New Zealand to do a postdoc. He's a hydrologist who has spent a lot of time working on the geology of the Southwest Pacific, and we'll be seeing some different aspects of that today. So I will hand it over to Nick, and maybe one or two latecomers popping in, but we'll jump in.
That's fine. Well, thanks for that introduction, Jennifer. It's a pleasure to be here. I know I'm the speaker because I'm the only one wearing a jacket. So you're getting your dessert before your main course today, with the supporting talk before the main Hochstetter. But there's a common theme to both, I suppose, and both are looking at big picture geoscience in the Southwest Pacific. The one this afternoon on stratigraphy is more New Zealand focused than anything broader, but I think there's still plenty in there for people. And those of you who know my background will be a bit surprised that somebody who's basically a hard rock meteorologist is fronting up a talk on stratigraphy. And I myself wouldn't have believed it a few years ago either, but here we are. There's, I think hopefully there's something in this for everybody, as the title implies. And at the very least, there's some nice scenic pictures about 2/3 of the way through that, so we can play a nice guessing game of where in New Zealand are we. So stratigraphy. Stratigraphy is a bit like good dress sense. It's hard to define, but you know it when you see it. Okay. And stratigraphy for many people is encapsulated by layered rocks, by strata. All right. But there's a couple of definitions of stratigraphy here. A formal one, it's basically a descriptive exercise or a descriptive phenomenon describing all rock bodies that form the Earth's crust, so not just sedimentary rocks, but igneous rocks, metamorphic rocks as well. And you organise them into distinctive units, and you do this for different reasons, but basically it's about classification of rock bodies. And there's a number of ways you can do this. You can classify them by rock type in lithostratigraphy, by their age in chronostratigraphy, by fossil zones in biostratigraphy, by their magnetic properties in magnetostratigraphy, by their isotopic properties in chemostratigraphy, and so on. There's a number of ways of classifying rocks. And there's a more cynical definition there, but no less a real one, and that often with stratigraphy it's easy to get bogged down in terminology. We're lucky in New Zealand there isn't any formal committee that validates stratigraphic names, so we're not tied to any kind of incessant debates and championing of these units. But nonetheless, that's something you've got to be aware of and not get bogged down in. So this talk is basically the backstory behind a paper, this paper that myself and 22 co-authors published in the last edition of NSAJGG last year, December 2014. This is an open access paper, so it's not paywalled at all. So if you're not part of the university or CRI, you can get to it from the Taylor and Francis website, and there'll be a little web address later on. And this is a paper, high-level stratigraphic scheme for New Zealand rocks. So this talk is basically the story of how we came to write this, and what I think the implications are and how it can be used by everyone. And the last slide of the talk will be a shameless plug for the journal, the New Zealand Journal of Geology and Geophysics, of which I'm the current senior editor. Okay, so after that last slide, we'll stay on topic on stratigraphy. Are the lights okay, Jennifer, or can we turn them down? I'll let you address that. So I'll take you back to 4 years ago, and this is the one of the meeting rooms at Geoscience in Wellington. Okay, and we have a meeting of scientists here. And we've met to discuss rather wordy GNS database interconnectivity project. We're getting together because GNS for many years has run a large number of digital databases. And many of these are publicly accessible. But they've all it's been about 10, 15 years since GNS paid any attention to developing or connecting its databases. And so it was long overdue that we took a fresh look. And what we wanted to do was to try and see how we could make some of these databases talk to each other, okay? Such that we could do more efficient database queries and get more out of the databases more easily. And one of the notions we came up with was that, well, actually, we could use stratigraphy much better because up to this point, the fossil record file database had its own list of stratigraphic names, the PetLab database had its own list, and so on. And QMAP used its own stratigraphic names, and the petroleum database likewise. But we thought, well, if we could actually have some sort of common stratigraphic names across all the databases, that will iron things out and make a lot of cross-database queries much easier. And so, bearing in mind this guy here, what we're using stratigraphy as a tool, not an end in itself. So the first port of call is the StratLex database. This is the digital version of the New Zealand Stratigraphic Lexicon. All right? And what this is basically a glossary of names, of stratigraphic names. So there's more than 7,000 of them. And these are both names that are in current use, but there's also every stratigraphic name that's ever been used in New Zealand, including obsolete ones, ones that are used only very rarely, ones that have been superseded. They all just pile up here, mount up here. Now there's a very clever thing about the StratLex database, it's hierarchical. So a formation knows which group it belongs to, and a group knows which supergroup it belongs to, and so on. So you can drill up and down a short way there, and all this is baked into the tables, the relational database tables in StratLex. So its strength is it's hierarchical. Another strength is that it's got lithostratigraphic, chronostratigraphic, biostratigraphic names in it as well. It's very comprehensive. But that's also its weakness, it's too comprehensive. If we've just I'll dial up the query page here, and if you tick the Miocene box, what Miocene units that have got lithostratigraphic names are there in Hawke's Bay? This is the result you get. There's 46 of them. And yeah, there's things like Ahuriri series, Hawke's Bay series, Haroto beds. So there's informal names, obsolete names, as well as things that look a bit more promising. So that's one sort of the first port of call for stratigraphic names in the digital era, if you like. The other one is QMAP, and most of you will be familiar with the blue-bound 1 to 250,000 scale maps for the whole country. The project was finished just a few years ago. And there's also a seamless digital version of QMAP online now. There's the web address there. And you can zoom in and set various backgrounds and transparencies and do a bit of pointing and clicking, and up will pop whatever polygon unit you've clicked on. So here we have Middle Miocene Tunanui Formation, part of the Tolaga group. As I say, this isn't talking to the StratLex database, it's just completely baked in within QMAP, just isolated within it. But wouldn't it be nice if a database like the fossil record file or the PetLab database, if you could punch in some kind of irregular polygon like that? The stratigraphic name, Tolaga group, is a very cunning combination of irregular geography, all right, and also age, and also rock type. So it's extremely efficient and distilled down way to query other databases. Wouldn't it be great if we could do something like this with PetLab or Fred, and find out what points or what samples have been collected from the target group within that polygon? Now the good thing about QMAP is that it's already provided a nice filter instead of 7,000 names, there's only just over 1,000 in QMAP. That's still a lot, but these are the ones that provide a very nice first order cut as to what's in current use, okay, rather than including the obsolete ones. Now, QMAP used a mix of chrono, tectono, and lithostratigraphic units. For the quaternary, QMAP used Q1, Q2, Q3, the oxygen isotope zones. So that was chronostratigraphic. All the yellow, pale yellow on the map was done chronostratigraphically. They used terrains for the basement, and for most units, the standard lithostratigraphic formations and groups that we'd be familiar with. So you can see there's a few issues to deal with here. And so something like PetLab, I could equally have punched up the fossil record file, fossil localities in New Zealand. These are rock sample localities. And I think I ticked the Auckland University box. Auckland University samples, the ones that we've got in are the pale blue, centred in the North Island, unsurprisingly. But this is where rocks have been collected, and it'd be great to query this on something like Tolaga Group to just separate out what we want rather than getting swapped by too many results in a query. As I say, PetLab's got its own strat names. So what we did was that top bullet point there. Okay, we within Stratlex we took the QMAP names and we kind of blessed them. We said these are the ones that we're going to kind of flag as being in use and related to each other, and then we will start to link other databases like Fred and PetLab to that set of names, and yeah, then we'll move forward by that, and we'll have succeeded in the aim of that database meeting at the beginning. We'd have started to connect things up. But of course, we discovered a lot of things on the way. There's lots of unanticipated issues. We had a choice between starting with a blank slate or starting with existing names, and we chose to, wherever possible, use existing ones. And what we wanted this to be a bottom-up exercise, not a top-down one. So by saying that it's going to be bottom-up, we retain maximum familiarity of units for everybody. There's also a choice between what kind of stratigraphy do we want to do. The oil industry in particular wants chrono stratigraphy all the while, but we chose lithostratigraphy just because there's plenty of lithostrat names around. They relate to rock type as well as age, and yeah, that's what we picked. And for database purposes, every unit needs a pairing. We wanted to define, if you like, topmost level names for like all the basement and all the cover rocks in New Zealand. But we discovered in going through Stratlex that there's only 8 supergroups across the country. They're scattered around the geological column. There's no sort of 8 groups don't cover the whole country. There's 168 formally defined groups that are not in supergroups, so they don't have any supergroup parent. And furthermore, there's more than 200 formation names that aren't in groups. So this was a bit of tidying up that we felt we needed to do at that topmost stratigraphic level. And it was also quite clear that I think because the stratigraphic lexicon and historically New Zealand stratigraphy has been the domain of paleontologists and soft rock geologists, that igneous rocks were pretty underdone and in a stratigraphic context. Remember that definition of stratigraphy right at the beginning. It's the classification of all the rocks of the Earth, not just the sedimentary rocks. So we wanted to redress that as well. And another thing we found, and I'll come on to this later, is all of the good names are already taken. If you want to define a new unit, you're not allowed to use the same name again. There can't be another. There's already a Te-Kuiti group. There cannot be a Te-Kuiti supergroup. Okay, and we found that every mountain and major river and province is already used for its forename is already used for a stratigraphic name. So that was another kind of problem we had. So to help you solve problems, there are guidelines, and the International Stratigraphic Guide, which also has a website, we checked that out, and there's some excellent advice for lithostratigraphic subdivisions as to how to define a supergroup, a group, a formation, a member, and a bed, what they are and how they relate to each other. But it doesn't tell you anything about how you might go about with a very high-level classification that could apply to a whole country. If you want to boil stratigraphy down to just a few units, a dozen units, There's nothing higher than they offer nothing higher than a supergroup for that, and we thought we did need something higher than that. And well, this is what we're doing isn't brand new. It's no surprise to discover that it's actually been tried and done before. And the person that's been instrumental behind this picture is shown here. It's Bob Carter, ex of Otago University. So over the decades, Bob and colleagues have offered this high-level scheme along these sort of lines. You can see geological time up the y-axis there. And back in Carter et al. 1974, you've got Kaikoura sequence, Rangitata sequence, Tahua sequence. These are unconformity bounded, allostratigraphic high-level units. Sequence, of course, has come to mean something very specific with sequence stratigraphy. And so in the 88 paper, the term synthem came in. A synthem is a high-level unconformity bounded unit. But for one reason or another, nobody uses these terms. I mean, the Kaikoura synthem paper is rightly famous and well regarded, but not well used outside the Canterbury Basin. All right, so it's never been really applied to across New Zealand, and I'm not sure why. It's maybe because it was seen as too parochial, too Otago Canterbury centric. Maybe synthems doesn't roll off the tongue very nicely. The point that Bob's made on several occasions is that a bottom-up lithostratigraphy naturally would slot into a high-level unconformity bounded or allo stratigraphy or sequence stratigraphy by another name at this high level. And so this quote here is the title of one of the sections of his 2007 paper. So he doesn't see it to be a problem to slot lithostratigraphic units, medium-level lithostratigraphic groups and formations into high-level unconformity bounded units, with which we agree, and we agree with him on that, and that's what we did. So the basis for these high-level names was QMAP, as I mentioned, and we also used this King et al., Peter King et al. 1999 compilation of stratigraphic names and sections from across all of the New Zealand basins. This is called GNS Folio Series 1, and it's not the best distributed publication, but it's not quite in-house, but there's some very good sequence stratigraphic principles outlined in there, and it was a very good kind of roadmap to defining what we wanted to do. It turned out that the basement rocks of New Zealand are pretty well served by high-level stratigraphic names. You've got terrains, we've got batholiths, they're big entities. But in contrast, the cover rocks of New Zealand were quite poorly served. There were no big supergroup names or mega sequence names to apply, and so that was the gap we were going to fill. We ended up calling our scheme Litho 2014. We branded it for a couple of reasons. Litho emphasises it's grounded in lithostratigraphy, not any other kind. And 2014 tells people that it probably can be revised in the future. Okay, this isn't the be-all and end-all, and of course it's not the only way to do things. And so in the bottom right of the slide there, we favoured pragmatism over principle, familiarity over consistency, and conservatism over innovation. Right. Why I draw attention to that is because those of you who are Geoscience Society members will have possibly seen John Bradshaw's comment on the lithostrat paper in the last Geoscience Society newsletter. And one of John Bradshaw's main criticisms was that we were mixing apples and oranges. We were mixing tectonostratigraphic units with lithostratigraphic ones with sequence stratigraphic ones. And we know that. That was that was certainly mentioned by many of my 22 co-authors, but in the end we favoured this pragmatism over principle and familiarity over consistency aspect. And being good GNS survey geologists, we wanted to be something conservative and familiar rather than too innovative. But it's useful nonetheless. So here's the team. Most of the QMappers, most people were happy to subscribe to this. And we also co-opted people from the Basin Studies group at GNS Science and some paleontologists there. And it's a very good opportunity, it's something that's not often done, to acknowledge the Carrie Bassett, who is the handling editor at NZJGG, and Lorna Strawn from Auckland and Ewan Fordyce from Otago, who are the peer reviewers for this paper. And yeah, they provided very useful input. It's quite sobering to look at the before and after versions of the original submitted version versus what came out. This is a lot more rigorous and better overall than what we submitted to NZJGG. Yeah, so the timeline then. So that database meeting, the picture I showed to start with, that was 4 years ago. We didn't actually start writing until early 2013, and it got knocked around quite a bit internally within GNS, deciding on route names and the if you like the forenames or the Christian names for the units, how we should go about it. Yeah, there was a lot of discussion. And but once we'd submitted it, the whole thing just took less than a year before it was published. And of course, it's very timely that I'm now on Hochstetter who are able to talk about this to promote it basically. So what did we do? Well, many of the next few slides are diagrams taken from this paper here. This paper's only got 5 diagrams in. This is a generic crustal cross-section through New Zealand. It's not meant to be a specific place at all, but you'll recognise that subducting slab and active volcano are meant to represent the east coast of the North Island. The parts over here could be Taranaki Basin, or they could be the east coast of the South Island, the sort of more passive margin. And you can recognise that the most important geological contact in the country between the cover and the basement here. It's this unconformity running through. And in the basement, even though you might not be able to read the individual names, you'll see that the basement rocks, which occupy by far the largest volume of crust between the moho and the surface, they're pretty well populated with terrains and things. Okay, even at this scale, when we want to choose 10, 15, 20 names across the basement, we're not worrying about formations and groups. Basin's pretty well catered for. Eastern Province, Western Province, terrains and batholiths, okay? In contrast, the cover rocks are not. There are no lithostratigraphic or other names you can apply at this kind of scale. And so we filled that vacuum. And so this is what we proposed or explained in figure 1 of the paper here. And for much of the rest of the talk, I'll be walking you and talking you through these names, how we came about them, which rocks they apply to. And okay, so first of all, you can see we divided the sedimentary rocks of the cover sequence into 5 supergroups, different colours marching up there, and I'll explain the names there. And collectively, we're calling these the Zealandia mega sequence. So if you want one name for cover, instead of using the word cover, you can now call it Zealandia mega sequence officially. Likewise, all of the basement, it doesn't really need a name, but combined Eastern Province, Western Province, we call it Austral Super Province. It's Super Province, and it's formed down in the south. So there we go. And here are the igneous rocks in the cover that we paid more attention to as well. We gave them some super sweet names, and I'll explain that later. So that's a geological cross-section, and you can also look at that. Another figure in the paper is a time stratigraphic diagram. So all we did was introduce 14 new names. Okay, the geology of New Zealand is still the same, right? That's not changed. But what has changed is every name that's surrounded by a red circle or an oval in here. So 7 of these names apply to igneous rocks. We found that we needed 3 more suites in the basement, in the plutonic rocks, to completely describe the entire package of granitoid rocks. And we needed 1, 2, 3, 4 names in the volcanic rocks of the cover to fully describe them at this scale. And the other names apply mainly to the sedimentary rocks. I've mentioned Zealandia mega sequence, Austral Super Province as big grab bag names. These are the Adam and Eve of New Zealand stratigraphy, if you like, the top ones. And here we have our 5 supergroups. And these match these colours here. I'll be talking you through the next few slides. We'll go from we'll go on a tour around New Zealand from the Momotu supergroup up to the Pākehī at the top there. But you can see these correspond to these King et al. 1999 second order sequence stratigraphic cycles. Okay, so the Momotu supergroup is this cycle 1, which is continental rifting. Cycles 2 and 3 here are the marine transgression across New Zealand from the late Cretaceous through to the late Eocene. Maximum immersion interval in the Oligocene. We've got another unit. And then the marine regression, start of subduction with the final acceleration in the late Pliocene, Pleistocene. So, as I said, these are bottom-up units in that we can plug groups and formations into all these high-level units. But, you know, at this highest level, they are intimately related to geological processes and major unconformity-bounded units or tectonostratigraphy as well, okay? Tectonostratigraphy is usually a term that you associate with the fault-bounded terrains, but sequence stratigraphy, tectonostratigraphy is also a basis for subdividing in that direction as well. So we'll have a little tour of New Zealand now. We'll see how good you are at identifying New Zealand scenery and outcrops. So here we have a couple of examples of the basement cover contact. They're both in the South Island, as it turns out. The one on the left, it's too closely cropped for you to know, but this is the shoreline of Lake Manapuri. We've got a Jurassic diorite overlain by the Oligocene Hope Arm Formation here, a conglomerate. This is a place just north of Dunedin, a Taigo schist basement overlain by Taratu Formation cover. So as I say, I regard this as the most significant geological contact in New Zealand. And now, if you like, you can describe it as, you know, Zealandia megasequence sits on Austral superprovince in the most general sense. So marching up through the Zealandia megasequence, Momotu supergroup, that's the first one. Now I mentioned earlier that all the good names were taken, right? So that we looked at Bulla, you know, we looked at a number of names for this. And in the end, we applied Maori names that would be appropriate to the tectonic setting of this particular unit. So the word Momotu in Maori means to separate, to sever, or to break apart. And why we chose this is because the rocks of this Momotu supergroup are part of this first order, part of this cycle 1. They're Sin Rift deposits. So these were being deposited while Zealandia was starting to break apart from Gondwana. Okay, as the crust was stretching, basins were filling. That's where we got the name Momotu from, as Gondwana was breaking apart. So does anyone recognise where we are in New Zealand on any of these? Some people must. Mike, Mike knows them all. So anyone else? This is the Clarence Valley in the top left. We've got Lookout Formation, intraplate volcanics. There's a person right there in the blue for scale. And these are interbedded with marine sediments of the Wallow group. Okay, so these are, say, late Cretaceous. They're in this interval 100 million years to 85 million years, approximately. Uranium Point is in the Bulla Gorge. Anyone driven through the Bulla Gorge underneath Hawke's Crag? There's these classic Pororari group breccias. And here's some of those red breccias down in the Kyburn Formation in Otago. So these are all kind of graben deposits, both non-marine and marine here, with intraplate volcanics erupting in them. And we can plug those, we can define, formally define in the appendix of this paper is your listing of which groups and formations belong to this Momotu supergroup. Okay, so again, it's a bottom-up thing. All we've done is say that a collective name for these groups and formations is Momotu supergroup. So this applies. You can stick your nose out of your own favourite sedimentary basin, and Momotu supergroup is a name you can apply throughout the country. So moving on up above Momotu supergroup, we have Harenga supergroup, and this is the the classic late Cretaceous to Eocene marine transgressive sequence that is present in every New Zealand sedimentary basin. The name Haringa comes from the Maori for a journey, a trip or a parting, and so this communicates that this is when Zealandia is a separate entity and it's moving north away from Gondwana on its journey to present day latitudes. Okay. And yeah, these are the constituents, just a selection of the constituent groups that may be more familiar to some of you, depending on where in the country you work. But yeah, now there's a collective name for all of this sequence. Instead of saying King et al. Second order cycles 2 and 3, you can call them all Haringa supergroup. So anyone would like to have a crack at where in the country we are with these three? You're very poorly travelled, aren't you? This is in Northland. Someone must recognise the one on the top left. It's Kutu boulders up in the Hokianga. Okay. So the late Cretaceous concretionary sandstones, more impressive than the Meraki boulders, dare I say it. This is Cape Farewell, northern tip of the South Island, so the on-land expression of Taranaki Basin. So, yep, Pakawa group. And this is Brona coal measures on the west coast of the South Island. It could equally be Waikato coal measures. Okay, you've got quartzo sandstones overlain by coal seams. So it's worth emphasising that these supergroups, yeah, they do incorporate a wide range of marine, non-marine lithologies. Okay, but we define this big conformity bound interval. So overlying this thick clastic sequence of this thick clastic supergroup of marine and non-marine rocks, we have the Waka supergroup, and these represent rocks that are principally Oligocene and relate to the maximum flooding of New Zealand, the maximum marine transgression, at which time an ocean-going Waka would have been very useful to navigate between the little archipelago of islands that was left in this interval. So that's where the name comes from, and yeah, obviously things like the Tekawiti limestone, Whangarei limestone slot into this. So let me try again. Anybody recognise where in New Zealand we are now? Yep, Waitomo area. Yep, sure. Yep, lovely fluted limestone cliff. It's very good. This is the bottom one is Greymouth. Yep, that's right. That's the bridge at Greymouth over the Grey River. Yeah, and Mike's right. That's the Forest Hill limestone in Southland. Later Oligocene, early Miocene limestone in Southland. I mean, that's how we know that New Zealand was underwent maximum marine inundation because there's limestones everywhere. Okay, there's a dearth of non-marine strata. So above Waka supergroup, the geology changes drastically. So that's the justification. We're into the onset of subduction, and we see a lot of emergence and again dominance of plastic sandstones. And so because of the uplift, the general widespread uplift for the onset of subduction, we thought the term Maui supergroup is appropriate after the legend of Maui fishing the North Island out to sea. It fits very well. And this corresponds to the couple of King et al. Sequence strat cycles to do with marine regression, but also the subduction initiation in Northland's an important aspect there as well. And there's a selection of some of the groups that slot into this across the country. Okay, well, people are bound to recognise the one at the top right, eh? That's the Waitemata group. So I forget exactly where north of Auckland that is, but I was on a field trip there 10 years ago. Could be, yeah, I've forgotten, sorry, but if people know exactly where it is. Somewhere between Auckland and the Whangarei Peninsula. Top left there is, we're in Southland, the Gore lignite measures. Okay, so there's non-marine beds there. That's one of the lignite pits south of Matara. And what about this one on the bottom? Very good. Good. Mahi is a good guess. and Castle Point's a good guess. So yeah, we're the South Wairarapa coast. Yeah, this is Whakataki Formation. Yeah, on the South Wairarapa coast. Again, sort of wall-to-wall clastics. Okay, so a very different tectonic regime. And finally, yeah, the very topmost part of the stratigraphic column. I mean, to date there has not been a lithostratigraphic term for all of the country as quaternary, but now there is, if you want to use it. And Pākehī means in Maori open grasslands or barren country, which would describe a lot of the flat plains, Southland Plains, Canterbury Plains, Manawatu district that would have underlain by these. Well, they're not really rocks; they're unconsolidated deposits. And yeah, so where are we? Anyone want to guess again? Cape Kidnappers, yep, Cape Kidnappers on the top left. Here we're not too far from Dunedin. This is Lewis Cliffs, Oamaru, railway line in Oamaru. And this is Southland Plains, just west of Invercargill, but it could equally be yeah, Canterbury Plains or Manawatu again. So that's the sedimentary rocks dealt with, okay, or the classification into which the sedimentary rocks fit. As I said, first of all, we also wanted to pay attention to the volcanic and plutonic rocks. The plutonic rocks in the basement are fairly well dealt with. But we thought, in terms of their subdivision into batholith, or a pluton is the fundamental map unit of a plutonic rock. And plutons is a twofold parent. There's a mother and a father for plutons. You can go a physical route, mappable route into batholiths. Is a pluton part of the constituent batholith, bigger entity, or is it? Additionally, is it which geochemical suite is it part of? If you age dating and geochemistry on a igneous rock, you can apply the term suite to it. So Andy Tulloch did that for the plutons decades ago, and there are more suites are being defined. But we thought, well, why not do that formally for the volcanic rocks as well? So we've QMAP does define volcanic provinces, zones, and centres. Particularly in QMAP Auckland and QMAP Rotorua, you see these divisions. So that's the physical mappable subdivisions there. What was lacking and what in red here, the three names we threw in here were geochemical suites, or in this case super suites, because they're rather overarching. Is a particular lava or a volcano there because there was a subduction zone underneath it to make it? Is it there because it was intraplate, nothing to do with subduction? Or in the third case, is it there just because it's a piece of a loch in this ocean basin? Okay, so we've got a kind of a threefold hierarchy now to match the plutons. So the high-level scheme for the lavas we came up with, they do use geographic names. Whakaari supersuite for any rock that somebody interprets to be subduction related. Suites are of necessity more interpretive and less descriptive than volcanic centres or batholiths. But Whakaari is the name for White Island. Haramaka supersuite for all of New Zealand's scattered intraplate volcanic rocks of any age, late Cretaceous, Oligocene, Miocene, present day, including Auckland volcanic field. Haramaka is the Maori name for Banks Peninsula, and this is the largest single volume of intraplate volcanic rock in all of Zealandia, actually. And finally, Te Rapua supersuite. This is the Auckland suite, so the Tangihua complex and Matakaua complex that have been thrusted in on the Northland Auckland. And this is named after the highest point in Northland, Te Rapua, which is held up by Tangihua complex. And I bet this is a slide you've never seen before, because yeah, it's never been made before. This is all, so currently, if you add in the new red names we've made and defined in this paper here, along with the existing ones Andy Tulloch and Roddy Muir and others have created, yeah, the entire igneous rock population of New Zealand can be boiled down into 15 different age and geochemical suites. So now you can go into PetLab, and you can query with a single stratigraphic name, one of these, and just extract the particular of samples and data for a particular suite that you want, provided that sample records have the attribution done. So yeah, there we go. Jackery suites is all the way from the Cambrian, right through to the present-day White Island there. This is the entire spectrum of igneous rocks in the country. And as I said before, well, I'll say it again, these are the rocks haven't changed. We've just applied some new names for them that we can, I think, provide for more efficient description of them. So at this kind of scale, you can actually use just a couple of names to describe one unit. And not forgetting the other dimension, both offshore and that depth dimension, equally, instead of describing these in terms of sequence stratigraphic units or cycles, you can now actually apply proper supergroup rock names to them, and you can see their geometries in 3 dimensions. Personally, I think this is a lot more tangible and useful than just dealing with concepts of sequence stratigraphy, because they lend a reality and a connection with things on land much better than formally. And getting towards the end of the talk now, where did that leave the database, which is where the whole project started. As I say, when we had that meeting, we didn't know we were going to write this paper or produce all these names in red circles and things. But we did intend to make the GNS databases talk to each other. And we did, thanks to these 3 people here. We've got some very talented applications programmers, Zoran Haubrock and Chris Martin, did a lot of the behind-the-scenes database coding and data cleansing, and Delia Strong did a lot of the PetLab attributing to PetLab. So she actually populated PetLab database with these high-level names, or even with low-level names, and then through what these guys did, you give a rock unit a low-level name, and it immediately knows where it is in the high-level sequence all the way to the top, because of how Stratlex already works. So now, if you go to PetLab, and I think Rose has been here with her PetLab roadshow. So yeah, this is two mentions of 2 promotions for PetLab in a month. Some of you are getting. This is the query page for PetLab. There's a line on there these days, Litho 2014 stratigraphic name. All right. If you click on that, you get a pop-up menu, and that pop-up menu has got more than 1,000 names in it, in alphabetical order. And you might think, what on earth good's that? Well, I've selected Tologa group there, okay? You select Tologa group, and this pop-up window appears, this one here, and you can see here's Tologa group, what we selected, but it's clever enough, and this is we're querying the Stratlex database now through PetLab, okay? This is not baked into PetLab, this is going to somewhere else. But Tologa group knows that it's part of the Maui supergroup, which knows that it's part of the Zealandia megasequence going up. And if you like, you can hyperlink and click on that, and it'll replace Tologa group with Maui, okay? So you can view the Stratlex hierarchy this way, or there's an appendix in the paper. And likewise, you're going down there, if you want to be more specific, then you can drill down in Tologa group. And you can look these up on a QMap, and they'll be there for you as well. So you punch in this query, and I didn't make a list of how many records this returns, but it's something on the order of 250 GNS and university rock samples are coded as belonging to Tologa group. And that's the results map, and you can see that looks pretty reasonable, doesn't it? It would take you a long, long time to extract just the Tologa group sandstones from the PetLab database if you didn't have that single query to do it. If you had to do it by geography and rock type and age, it would take you for a long time. But we can get straight to what we want now if we want to access samples in a collection, university collection somewhere. So, yeah, well done, chaps. Good job. So this is the last slide of the stratigraphy talk, and in a minute I'll talk about NZJGG, the journal. But just to summarise what we've done, and we'll end on an assertive note, I think. There was a lot of discussion, uncertainty, indecision in the making of this paper, but we're actually quite pleased with what's happened. Not just with the database either. And this Litho 2014 scheme, it's comprehensive, okay? It takes into account the entire crust now of New Zealand, and it's of a national scope. And we no longer have orphaned formations or orphaned groups. Everything feeds up into one of those supergroups or super suites, and ultimately into those Adam and Eve units. Despite the new names, it's familiar. Yeah, so there's lots of your favourite formations and groups are still in here. Okay, they've not been superseded, and we've been as parsimonious as possible. We've only made up new names where we have to. It's very accessible. As this is an open access paper, it's not paywalled, and you've seen how you can find these things in the public databases as well. So you can dine them up pretty easily. We can do our new database searches, and there's some flexibility in how you treat igneous rocks. You can either go via the supergroups, or via super suites, or via volcanic zones, whatever suits. Okay, you can search for it, and it knows what its parents and what its children are. We think it's stable because it is fundamentally descriptive, okay, and it's based, this bottom-up classification is based on existing units. But because we have used these concepts of sequence stratigraphy and allo stratigraphy, it's quite powerful. We know we've broken a few rules, but hey, you know, it's published now. we've got it out there. So maybe other countries will be able to learn from us and how we've done it. And another interesting thing is, we didn't anticipate this might have educational value, but as I've gone around the country, this is the 4th time I've given this talk at the University Centre. I mean, people are seeing the educational value, both for university teaching and for public communication as well, as to the Maori names relating to the geological events and processes. So yeah, they'd be great if there's some uptake on that. And another thing is that it's worth mentioning, it's optional. You don't have to use it. You can go on treating the rocks however you have done up to date. And yeah, we're not going to worry about it. But we took great pains not to say that this is preferred or mandatory, because it isn't. Okay, it's only if it's convenient. Use it. And one gratifying thing is that obviously it's attracting some attention. The paper's been published just in a year, and already it's had 680 downloads from the NZJGG website, which actually makes it the 13th most downloaded paper from NZJGG since Taylor and Francis took over. So that's fantastic. And I like to think that Paul Crining and Bob Carter would approve of what we've done. I think we've always worn in mind the principles they've laid down, particularly this guy here. We haven't gotten bogged down in endless nomenclature. I think if anything, we've streamlined things. So we're pleased with that aspect as well. All right. So we published this in NZJGG, and yeah, that might seem like a no-brainer, and I suppose it was in a way. In that it's a New Zealand-focused paper, and so we pick a New Zealand journal. I'm the current senior editor of NZJGG, and you recognise some of my fellow associate editors there. One of them, Cathy Campbell, is in the audience here, and Shane Cronin is now at the University of Auckland as well. So yeah, we're the people that handle and process the papers for the Royal Society and for Taylor and Francis at NZJGG. And just recently, the 2014 impact factors for all of the world's scientific journals have been released. And I can show you a good news graph. It's always great to see graphs going in that direction, isn't it? The impact factor for NZJGG has never been higher. We're above 2 now, and that's very good. So what I'd say is that yeah, NZJGG, despite it always will be a local journal, a national journal, in a global pond, right? But we're actually pretty pleased with where we rank internationally. We're halfway up and a third of the way up compared with other earth science journals. On the back of this increase in impact factor, Taylor and Francis have given us a 20% increase in page numbers, publishable page numbers from next year. Okay, so we have increased capacity. So if a low impact factor has ever been a factor for anyone in the audience, but they're not submitting manuscripts to NZJGG, I would say that shouldn't be the case anymore. We're pleased with the way things are going, and yeah, we look forward to getting the manuscripts. And now I will leave it. Thank you. factor is solely to do with citations. Okay, it's a number that relates to the number of times a paper has been cited in the journal in a 2-year moving window, or any journal in a 2-year moving window. Yeah. So if you've got an impact, factor of 1, it means that every paper's been, for example, that could result from every paper being cited once in that 2-year interval. So it's something like geology or tectonics have impact factors of 4 and 5. They're the top geoscience journals. Nature and Science, of course, are way up there. And a lot of medical journals are much higher as well. It varies by discipline. Just to do with citations, who's citing papers.
Comment on the cost of the journal. It's essentially inaccessible to anybody who's not affiliated with an institution. The online journal.
Yes, well, that's one of those things that's outside our control, unfortunately. But the subscriptions are what they are. Taylor & Francis charge what they do, and there are no